So, welcome to this conference, also from me. It's a pleasure to meet experts in the field of sky cultures. I have, around 2008, I have started to find Stellarium on the internet, and I'm very happy that among us also the project founder of Stellarium is today with us, Fabien Géraud. It's a great pleasure to meet you for the first time after like 12 years of collaboration now. Now my research area, well, I'm a computer scientist and astronomer, so my interest is cultural astronomy. This word I haven't known 10 years ago, or I started to know 10 years ago. For me, it was always astronomy in culture, culture in astronomy, astronomy in the history of mankind. This is my key interest. Now, what I've been doing is I've used Stellarium to not develop sky cultures, but to develop archaeoastronomy. And I would like to give you a brief overview of what Stellarium is capable of right now after 10 years of further development. And I think Stellarium can be already said is easily the best outreach tool, almost perfect outreach tool for astronomy, for many kinds of astronomy. Over the last years, I have solved many of the accuracy problems that early versions of Stellarium had when it was developed for contemporary amateur astronomers who just wanted to go outside and observe the sky. All these long-time effects, when you want to simulate the sky of antiquity, then you need to apply better models. And what we did, also with a couple of students of mine, we developed tools for virtual archaeoastronomy. And in the last part, I will give you an overview of the current state of the sky cultures. Susanna has already given you some aspects. Yeah, as you know, many cultures have built temples or other sacred buildings, and many of those have some relation to the sky, to sunrise, equinox, and or solstice, or rather solstice, or other features. Maybe some are aligned with stars in mind, or even with the planets. Just want to put that out. Losing the focus. So my field is called virtual archaeoastronomy, which is a terrible mixture. For this to develop, you need knowledge of astronomical phenomenology. Actually, there should be a movie. I'm afraid there's a codec missing. You need knowledge about astronomical phenomenology. This is my field. I've learned astronomy in primary school, basically in the Vienna Planetarium. You need interactive computer graphics in order to have animated pictures. And then there is the input of archaeologists who actually dig out all these things and rebuild structures and survey structures, and maybe already building virtual models of their structures in the term of virtual archaeology, mixing of archaeology and computer graphics. And there is the connection between astronomy and archaeology. It's called archaeoastronomy. And then there's the connection between astronomical phenomenology and astronomical and computer graphics, that is astronomical simulation in terms of desktop planetarium programs. And in the center of all this, I firmly place Stellarium. Stellarium is a wonderful program. It's multi-platform, runs on all the major platforms. It provides a very pretty sky simulation, has done so from the onset. So what Fabien and his first team has been doing was really fantastic. And most of these things, most of the look and feel of the early Stellarium is still inside the current program. Yeah, unfortunately, the movies don't work. You get super wide angle views, and you can have several projections. You can exchange the constellation patterns, which makes them very attractive, of course, for the research in sky cultures. You can add photographic horizon panoramas. That means you can put yourself onto a location surrounded by whatever mountains or other landscape you have. And Stellarium can be extended by plugins, by extras, by add-ons that not all users may need. There are plugins for telescope driving, there are plugins for quasars, pulsars, whatever, extra objects. Susanne already presented the online query plugin, so if you want to have extra information for a particular star, you can query other websites. Well, given that it is an open source project, which is great, you can just, if you know how to program, you can go into the source code and fix things where you think it should behave different than what you see on the screen and add your corrections. This is what I've been doing for several years now. Now, when you say Stellarium, it's a family of programs. So I'm talking, and I'm only developing in the GPL version of Stellarium, which was founded more than 20 years ago. You won't believe it. It has a long tradition. When I found it first, it was already a couple of years old, and there were several forks that almost look like Stellarium but are not Stellarium. And if people see, that's Stellarium, that need not be. There was an early fork from one of the co-developers who made a planetarium system out of that. It's called Nightshade. From this, several other projects forked off, and so there's a continuous development in this area. Now Nightshade made a next program that is not related to Stellarium code, but it still, I think, looks quite similar. Of course, it must look similar because it has a starry sky. Then there was an early mobile version of Stellarium that was made by Fabian's brother. And finally, Fabian and his brother developed yet another new, a totally new system that is also that does not share source code with the old version. One runs in the web browser, and the other one is the new mobile and mobile plus versions, which are on your smartphone. I think it's both Android and Apple. So that's a new mobile system, which is of course very practical for, you know, most computers are the smartphones nowadays. So it's the availability of the software. Also, if you're going out in the field with just a small device, it's really a good idea to have these things also on a smartphone. Of course, it does not have the same features because, as said, it's a different source code base. And then there are even dead things like a very early version as well. Somebody just ported whatever was available into Java, which was popular at that in these days. Ported once and forgot the whole thing. So this is a dead investment of time. It's better to just put your energy into the mainstream Stellarium development and add interesting things there instead of porting to languages which well, did not really take off that much. So when I first saw Stellarium in the early 2000s, it already looked quite nice. And it was beautiful. It was there was also an award-winning in these early years. If you look at Stellarium today, well, it looks almost the same figures. We have a set of sky culture paintings made by a Belgian artist. And you see, well, the sky simulation is quite similar still today. What has changed? Now, of course, the astronomical accuracy. When you are going into long-time simulation, you need good astronomical models. So also the first team already had used the VSO P87 for the planet positions. It's a classical theory from the 1980s. But it only goes back to, it is recommended to be used back to -4000. If you go further back in time, you need better models. And there is one term, a few years ago, Donald Giermans was in Jena. He's from JPL, and he attended a meeting of one of my astronomy clubs. It was fantastic. It was 10 years ago, and I talked to him. I showed him Stellarium, and I asked him, I have seen on the web you have made long-time simulations, but they are not available. And he said, okay, wait a few months. We are just working out our next long-time simulation, and this will go online. We will make this data available. And this is the really in the same year, the DE 431 came out, which is computation, a numerical computation from -13,000 to +17,000. So 30,000 years of astronomical data. You have to download and install a 1 gigabyte data file, and then you can access all those positions. So you can go back in time to -13,000 to get planetary positions as accurate as JPL can compute them. And we can simulate that. I added a long-time model for precession and obliquity. So the first version of precession was just a very simple model. Now we have really an accurate model that has been only published a few years ago that is capable of simulating Earth's axis orientation in space for many tens of thousands of years. I added the current notation model. So only the simple one, but it's accurate to arc seconds and not. I don't go into arc milliseconds. We don't really need that for our purposes. Delta T is a very important thing if we model the slowdown of Earth's rotation. That's very important if you want to simulate eclipses. We can go back in time until the earliest eclipse records, reliable eclipse records. These were of approximately 720 before Christ. If we go further back in time, we may extrapolate a bit, but not too much. So it's still not okay to try to simulate solar eclipses in the Stone Age. You will just make errors. Doesn't really pay off. And yeah, for many years I've said there are still two big things missing: axis rotation, so the axis orientation of the planets, and the other one was the annual aberration of stars. That is just a tiny shift that is still very important if you want to compute star occultations by the moon. And well, if the COVID crisis had one positive aspect, we can say it gave me enough time in home office to complete all these things. And finally, we have everything that we really need for astronomical phenomenological simulation in antiquity and prehistory. And still there's more to come. Then Stellarium is based on the Qt library of software development, which also had a major step 2 years ago. So we said, when we now finally want to drop the version number 0, we should also step up onto the new Qt version, Qt 6, which we did also in 2 years ago. And finally, last year, we said, okay, we can now finally, after 10 years of waiting, I think the first team discussed dropping the 0 at the version 0.10 point something. And I said, no, stop. let's finish the astronomy first before we drop the 0. 0 means it's unfinished, it can change, it has problems, it is unreliable. Now I think the numbers are really good. And we're now based on Qt 6. That means we should be future-proof for the next, at least, let's say, hopefully decade. After that, somebody else will probably make the next nice program. And we have a new Twilight model, a new Skylight model, actually, by finally a third developer who joined us last year. So for the last 10 years, I was together with Alexander Wolf. We only were 2 developers who maintained and continued developing. And finally, we have, since last year, a third developer who is now very active in also improving all the computer graphics details. It's incredible. He's finding things. It's very good to have new eyes to find old rotten things that just are old code that we just kept running, but did not really care to improve and modernize. And we have another contribution by a non-permanent member who provided eclipse details that are very nice. You can download, you can compute a table of eclipses, and then there is a button, download a KML file. And with this, you can open that in Google Earth, and you see the shadow path of the total solar eclipse crossing the Earth. That's really a great new tool as well. Now, what can you do with Stellarium? You can add your landscape. There are many ways to do that. You can either make photographs, or you can make a simulated landscape with Google Earth, or with Hey, What's That? That's a dedicated website for making. Actually, it was invented to compute radio transmission signal stations, but now it's also usable for making artificial horizons. There is Andrew Smith's software that you can make artificial panoramas on your computer, and many other things. And such a horizon panorama is not only capable of showing what is covered by the actual mountains. We've added also features to simulate light pollution. So you can, for instance, make a simulation of this harbor in Malta, and at night you will see all these lights coming on and casting rays into the air and actually greening the night sky. But unfortunately, in these days, it's also important to simulate that. Now, a panorama is fine. If you have an archaeological site and you make a panorama, the panorama geometrically is basically a sphere where you map a panorama photo on top of that. And if you need to go to another site, you have another panorama. And if you want to walk around in the site or between sites, you need one panorama for each position. Now, wouldn't it be fine if you just had a model of a 3D model of the scene that you walk around in this model and you have the correct cover of horizon and mountains and so on. As you are standing here, you can follow building axis and so on. This is exactly what we have done. We've added the Scenery 3D plugin. So whatever kind of modeling workflow you can apply, you can model a landscape with a GIS system, or there used to be a way to download the landscape also into SketchUp, into a very simple modeling program. Then you need to model, of course, your archaeological buildings. You may have already a laser scan of that or a photo-based model. And so you can put all this together into what we call a georeferenced OBJ file. OBJ is just a data format for 3D models. It's very common, very easy to create. And then you can load these models into Stellarium and walk around and immediately experience what it must have been like to walk through the Temple of Karnak in Egypt, for instance, or walk through Stonehenge and observe how the sky of these times has looked at the right position. You can also observe shadows. You know, this famous shadow in the Chichen Itza pyramid. It may not have been important to the Maya, we don't know that, but still it's now important for tourism. Yeah, you can see this shadow snake forming along the staircase. And yeah, you can also model this now. So you can take a model with you and simulate the shadow over the year as it evolves. I think it's a very good also research tool. Here's the Temple of Malta, one of the temples. We visited that during the conference and we made photographs, and later I got a laser scan of this temple, and you can see for the same minute here the result of the shadow simulation in Stellarium. I think it's really excellent. Now these are static models. If that's not enough, you can also combine Stellarium with a game engine. So Stellarium renders the background, the sky background, and you are running around in the game engine and actually interact with scene objects. You can play with instruments from antiquity or from the Middle Ages, or you can have a pond with curly water that reflects the sky. It's quite a beautiful scene, I would say. You can place birds in the trees that make noise. Or you can, as I said, you can use old instruments to observe the sky and take measurements, as it has been in Maraga in the 14th century. Now, our institute also made some research in Stonehenge, and finally we made a large exhibition in the museum in Austria. The Skyscape Planetarium, we had a wall 25 meters wide and 4 meters high. We used 5 projectors to illuminate that, and we explained the story of Stonehenge as it behaves, as it evolves. And so we took the visitors through about 20 minutes show where we explained, where we had scenes in the landscape as the landscape evolves. And whenever you needed astronomy, whenever you needed summer solstice sunrise, for instance, Stellarium was there to simulate that perfectly. We did not use the 3D mechanism for this. We only had 2D panoramas, but with the changes in the illumination, but just by the sky model, it almost was 3-dimensional. We also developed several plugins, the remote control plugin that allows me to hide the user interface. As you know, when you open user interface panels, they are in the scene. I wanted to avoid that on the big screen, so we made a remote control that's running in your web browser, and I could use my tablet to control Stellarium. We made a remote sync plugin that allows you to connect several instances of Stellarium on the same network. That means you can synchronize them, either showing the same scene, that means one master is controlling everything and all the other screens show the same, or we can exclude some of the synchronization data items that we can say we show 6 screens with 6 different sky cultures, and whenever I'm looking around on one panel, all the other panels will do the same movement, but they show, for instance, the same sky, show different sky cultures. So you can compare those on several screens. Or one can be configured to show the view in a telescope, and the other one has a wide-angle view. So that means you can always see several contexts of Stellarium. I think it can also be very helpful in particular installations. We've already talked about the plugin for supernovae. Alexander Wolf has developed that one. These are the typical light curves that are available. If you find better models, please don't hesitate to suggest better models. We are always open for improvements, of course. But showing a supernova, there's one famous supernova from 1055, when in Europe it was still not even thinkable that something in the starry sky changes. It was no topic. So we have no records from Europe about this one, but we have a very nice record from China that was a guest star appearing, and so it's of course fair to show this guest star in the context of Chinese constellations, which is just possible with Stellarium. I don't know of any other desktop planetarium softwares where you can just apply different sky cultures. So yeah, this is the point where I'm going now to show you the current state of sky cultures. What about the time? Okay, yeah, that's perfect. So the current state, as most of you will know, is when you see a very well-known pattern. The International Astronomical Union has defined regions in the sky that they call constellations. It was necessary to depict borderlines between the constellations to assign stars to constellations when they cataloged variables and binaries. So we have these straight lines. This used to be, for the last 100 years or so, this used to be the official status of the IAU borders. 90 years. Then most at least amateur astronomers know these constellation stick figures. And also from earlier times, from the atlases, we have just seen Bayer and Schiller and Hevelius and so on. We have these artwork figures. We have a genuine home pattern made by Johann Meuris. By the way, many of these atlas figures have been made by people called Johann, Jan, whatever. It's a funny coincidence. Also, Jan Meuris is still a Jan. In modern times, the name asterism is used to describe a constellation pattern which is not one of the official constellations one of the official 88 constellations, but sub-figures or figures that are unofficial, like the Big Dipper is not really a constellation, it's just a part of a constellation. So we can, these are called nowadays asterisms. The word asterism can also be used in a different context, just describing any pattern of stars. But this is the way it is contemporarily used now in usual, also amateur astronomy. And Stellarium is capable of showing long lines. We call it ray helpers, in lack of better names for that. If you know better names, alignments maybe, these are lines that help you orient in the sky. There's a 7-star line that can help you find, or there's this curve from the Big Dipper, the handle that goes to Arcturus and Spica. These things can be helpful in this context. Now, many cultures have different constellations, so we can show the European tradition. Of course, the Asufi is not really very different. Asufi mixes the Ptolemy sky with some remnants of the Arab sky, of the old Arab sky, but it's mostly Ptolemy. We have a genuine sky culture for Belarus, which in fact shows the Wagon, which is also a tradition in German-speaking countries, instead of the Big Dipper. And we used to have a very nice sky culture, the Ojibwe and Dakota sky cultures by Annette Lee. Unfortunately, she has found that these were used in a planetarium show, which was against her original intentions. So unfortunately, she has withdrawn this sky culture. It's unfortunate, but we cannot change that. The tribe's elders didn't like that. And therefore, we had to improve our setting about sky cultures. I will go briefly through the files that you have to define when you're developing your own sky culture. One is a very short file, but you make a new directory with all the files in it. One is a very short file, info.ini. It just has the name of the sky culture as it is shown in the Stellarium menu. You can add information about authors, Boundaries is a very important entry, whether you have your own boundaries or just adhere to the IU boundaries, or whether you have no boundaries at all. Like most of the ethnographical sky cultures just don't have boundaries. And we have added a new scheme, a classification scheme, which is we try to help that to get information about how accurate, how good this sky culture is, or what kind of sky culture is this. Is this a traditional description of somebody living inside the culture? So has this written by somebody who wants to tell others about their own sky culture, or is it the work of an ethnographer who went into the field and asked some indigenous tribes, asked them about their stories? Or is it a historical sky culture that somebody has tried to reconstruct from cuneiform tablets or from Latin scripts or from other sources? Is that a sky culture that is a snapshot of one single work? If you want to depict all the atlas figures, all the figures of one particular atlas, you say it's one sky culture. I would like to have this atlas on the Stellarium sky without any other information. Then you make a single sky culture where you also only have the star names of that particular atlas. This may be important for some to just not have all the other star names, just use the names that are available in that atlas. Or if you make your own inventions, there was some kindergarten group in Norway who did some new modern cultures like the hamburger and smartphone or whatever. And then if we see, we had still old data. Yesterday we discussed there's one sky culture that actually Susanne wants to get rid of because it appears to have errors. I don't know that. So if it's so bad, or if we see it's bad and it basically is lacking information, we need good documentation. So we can just flag them as incomplete, and hopefully somebody can fix that and improve that, replace it with a better one. And yeah, with this happening about NLP's work, we now need all the contributors to add a license to the data. We recommend using a Creative Commons license that allows you several things: either show it for everybody, use it for everybody, also apply changes or don't apply changes, make it available for commercial use or not. And if it's not for commercial use, you are not allowed to show that in the planetarium. The planetarium owner, the one who makes the planetarium show, is responsible for adhering to the licenses. Of course, we like, as an open source developer, we like a very free license that allows you to show it everything and under every circumstances. But as said, some tribal elder people will not like the planetarium selling tickets for seeing this data. Now, the next important file is, of course, the constellation names, which used to be like this, three columns. You need an abbreviation tag that is used in other files as well, just as an index thing. In this case, it's just the IU abbreviation, but if you have other constellations, you can invent your own. Then this is the name in the original language. In this case, for the modern sky, we just use Latin as the basic language of all the modern sky cultures. And in brackets, we code it like this, is a translatable name. And we're using hundreds of people for translating on a web service that is called Transifex. So people are helping translating it into their own languages. And this text is provided there, and we hope that somebody applies the correct translation. Then there's the next file that shows you the actual layout of the constellation stick figures. So you have the same abbreviation that is used here. Then you have the number of how many pairs of stars, how many lines you're using, and then you have pairs of numbers. It's always 2 points. These numbers are Hipparcos indices. So it's the star number in the Hipparcos catalog, which Stellarium is using for plotting stars. And so you just decode your constellation pattern. And so if you want the Aquila, this is how you code. You take just 2 stars and make these pairs. To apply artwork onto the sky, You would have another file, it's constellation art. In this case, you have you need to have the file name for a drawing, and then you have 3 points, 3 numbers per star. These are the actual X and Y coordinates and the Hipparcos number, and the constellation artwork is linked with only 3 stars. And that means when the artwork, when the pattern is very large, and maybe the original painting was in a different projection, it may be a bit distorted against the stellarium sky. This is something that should be remedied, but I have no full conclusion yet as how this really could be improved. I think I've asked you for 10 years ago when it's possible to improve that. But you know, well, it is a thing that we all want to have, but nobody has time for really doing it. Yeah, the star names is very important. Alexander has collected hundreds of star names, and at some point I said, well, how do you get this strange name? Where do you get this strange name from? And Alexander said, yeah, yes, this is from this or that book. I've never heard about that book. Now I said, please, it's impossible to collect 2,000 star names if you don't give references. So now we are adding reference numbers here, and in a different file we give the references. Where do we get all these star names from? There's one very strange entry. This is this manual from Jack Rhodes from JPL. Here's very okay. Yeah, and so on. So you see, most of that is in the guide. The final result looks like this. So you have the full description of a sky culture, and these references are now listed here. I would like to add a feature where you can, as a user, select which references you want to have and which ones you want to suppress, so that you can remove all the strange names that you don't like. You see the license entry, and yeah, as future challenges, there's a lot of things to ask, whether we have seasonal constellations or different aspects of planets, morning star, evening star, if there's any other things. Whether we could make a temporally evolving sky culture, at least as we know it, when you set the time of Stellarium, you could have Babylonian or Ptolemy or other European traditions as they are evolving, so to exclude the sextant from the skies of antiquity, for instance. But there's only 2 traditions where we have these sets. Yeah, there are several more nice ideas: zodiacal versus lunar stations, dark constellations. Stephen Galberg has written a paper on that. I know how to code them. Still has to be done. The Arab sky culture has single star constellations that we need to add. Yeah, the worst part is translation issues, but I think we can discuss that in the later sessions. Translation is really a terrible thing for people who are not used to translate, to have the academic translations that have been already done in, let's say, the 1920s. We should use those old constellation names that are already available and not invent new translations. But this is something also for the translation team to adhere. So maybe we should have some dedicated constellation translators that are experts in the field of that. So, as I said, there's still room for improvement of all these things, but there's not enough time to present all of these gaps. So now I thank you for your attention. My own address will change. I'm leaving LBI Afro. Actually, LBI Afro is leaving the world. We are dissolving ourselves at the end of this year, and I don't know yet where I will be in January. I hope this address will continue to be active, at least for some time. Thank you.